So now let's recap search algorithms. We have seen uninformed search that use no domain knowledge, and methods using uninformed search include BFS, breadth first search, DFS, depth first search, DLS, depth limited search, IDS, iterative deepening search, and UCS, uniform cost search. We also have seen informed search that use a heuristic function that estimates how close we are to the goal. And methods like this include greedy search, A star, and also IDS star that we didn't see, but you get a chance to play with it in the homework assignment. It's basically an IDS using the A star trick of using the heuristic. To fix the idea, let's talk again about DFS and how it looks on a tree. So DFS searches the tree branch by branch, which means that we're going to explore each branch until we reach the maximum depth. So we're going to explore this first branch in green, then the second branch, which will actually be the second sibling of this node here, then the third branch, the fourth branch, the fifth branch, etc., etc. So remember here that we have a fringe to keep, which are the next nodes to explore. In this case, the fringe, also called the frontier, consists of unexplored siblings of all ancestors. So when you explore this node here, you're going to put both of these nodes in the fringe. You explore this one, this remains in the fringe, but you're exploring these nodes here, so you're going to explore these two nodes. You add these two in the fringe, but you explore this one first. So all of these remain in the fringe until they are explored. So at the end, you're going to handle, need to put these members in the fringe, and whenever you finish a path, you need to go back and pull things from the fringe, pop things from the fringe to be explored next. So the search proceeds by exhausting one branch at a time. So how about IDS? So in contrast to DFS, IDS will search subtree by subtree rather than branch by branch, where each subtree is going by increasing the depth limit. So we're going to first have a depth of 0. And we do a DFS on that. Then we have a depth of 1, we do a DFS on that. Depth of 2, we do a DFS on that, and so on and so forth. So we're going to explore this way. So thinking about each iteration is simply an instance of depth limited search, where the search proceeds by exhausting larger and larger subtrees. So we're going to just expand that tree, and we would stop whenever the limit is reached. How about BFS? So remember, BFS is going layer by layer, with each layer being organized by node depth. So I'm going to explore this first layer, layer 1, layer 2, layer 3, and observe that as we go, we are going to put all these elements, these nodes in gray, in the fringe, which means that this will be next to be explored. And we wouldn't go to the next level unless we really have explored. We don't go here unless we have explored all the nodes in this level. So we keep going. And the fringe here, or the frontier, consists of the nodes of similar depth of the horizontal line here. So initially, we have the two elements in the fringe. When we move to the next layer, we have these elements in the fringe, etc. So how about UCS, uniform cost search? It's going to also search layer by layer, but in contrast to BFS, it's going to be organized by path cost rather than by depth. So we're going to have elements explored all over the place in the tree by prioritized by the cost till the node. So it could be, for example, this kind of search. But observe again that the gray nodes correspond to the elements that are in the fringe. So how about the fringe? The fringe, or the frontier, consists of the nodes of various depth. It's a kind of jag. The main reason is that it's prioritized by the lowest cost. So it's going to be this fringe and then this one. Depending on how we are exploring the tree, we're going to pick from here and there, depending on the cost of this node. So it's going to be jagged. And as comparison, let's do it again. So as comparison to the BFS that does this search layer by layer, the layers in this case are rather picked by the cost. So it's going to be something, layer by layer, but quite jagged in the search. Interestingly, we can organize this algorithm into pairs, where the first element of the pair proceeds by layer, and the second element of the pair proceeds by subtree. So for example, if we iterate on node depth, then BFS will search the layers of increasing node depth, while IDS will search subtrees of increasing node depth. So schematically, it's going to be for BFS doing this, while IDS actually will do this. That's the first tree, then it makes the tree bigger, and then it goes bigger, etc. If we iterate on path cost plus heuristic function, so remember we use the function f. The function f is for heuristic search, that is a function of g plus h, so the h is the heuristic and g is the cost to the node. So A star will search layers of increasing path cost plus heuristic search, in other words f. And IDS star, which is a variant of A star using IDS, which is iterative depth search, searches subtrees of increasing path cost plus heuristic, which is also F. Finally, I would like to emphasize which function to use for which method. So for example, for UCS, uniform cost search, it searches layer by layer of increasing what? Of increasing path cost. So it's going to work on the function using the function G to pick which nodes to explore and pick those that have the smallest cost. Greedy best first search searches layers of increasing heuristic function, and this heuristic function is H. And finally, A star search searches layers of increasing both path cost, G, plus the heuristic function, which is H. So it's going to be the function F equal G plus H. So that's the path from the root to the node plus the heuristic or the estimated cost from the node to the goal. That's it for the recap on the search methods. Thanks for watching.